So welcome everyone. Thank you for joining. Good afternoon, good evening, good morning, wherever you're joining in from the world. We're really excited to be here today for today's session, where we're going to be talking about distributed SQL, its benefits from a performance perspective, and some tools that are available to you today to optimize performance in CockroachDB. So we can start out with a little round of introductions here. So my name's Megan. I'm on the product marketing team here at Cockroach Labs. I've been at the company for about 3.5 years, so seen a lot of exciting growth and development of our product over those years. And I'm joined live today by Kevin from our product team. So Kevin, you want to give a quick introduction?
Yeah, sure. Hi, Megan, and hi, everybody. I'm Kevin. I'm a product manager here at Cockroach Labs, focused on SQL observability. So how do we focus and enable users to monitor and troubleshoot database issues that can be causing performance issues?
Yeah, and while he's been here, Kevin has made a huge impact on our observability tools. So major shout outs to him and the work that he's done. So today, as I mentioned, we're going to be having a conversation about distributed SQL and SQL performance. And we actually brought in one of our customers, Scott, who comes from a company called Yohana, which makes a pretty interesting personal assistant software. Scott was traveling this week, so we ended up actually recording a conversation with him last week, a pretty fantastic conversation about his use case and what he uses CockroachDB for and how he gets the performance he wants. So we're going to be playing that recording during this session, and Kevin and I will be standing by to answer your questions. So if you do have questions that come up, please drop them into the Q&A section, which has a little someone just dropped something in there just now. So drop your questions in there. We'll answer them throughout the session. And then we're going to meet up again live after we play the video recording to answer additional questions. And then Kevin has a great demo prepared, a great live demo prepared to show off some of the cool capabilities that we have recently released. But before we jump into the video, I know there's a lot of excitement about the limited edition t-shirt that we're going to be offering 50 people who are here on the call today. So this is very limited edition. I don't even have one of these shirts. No one has one of these shirts yet. I don't think I'm going to get one of them, unfortunately. So this t-shirt we actually made for our release that we just had in December. So we do 2 major releases of CockroachDB a year, as well as more continuous releases to our cloud platform. And one of the big themes of this release was how to optimize SQL performance and get the most out of your distributed SQL database to really meet the needs of your application. So that's it's a great theme, a lot of reflecting a lot of the work that Kevin's been putting into the product. And we'll be following up afterwards after we pick the names out of the raffle for people to fill out a form, and we'll send you these super limited edition t-shirts. So get excited for that. So I'm going to go over and start playing the recording of our conversation with Scott. And as I mentioned, we will be here responding to all the questions that are coming into the Q&A. So please do, let us know what's on your mind and your thoughts and your questions.
Hi, I'm Scott Bolduc. I am currently leading the infrastructure and tooling teams at Yohana, largely made up of the site reliability team, where we also focus on observability.
Awesome, welcome. Well, thanks for joining. So we're going to be talking through some exciting topics today, and they're related to distributed SQL, the benefits it offers, and some of the the performance related to SQL and running distributed SQL in multi-region settings. And then Kevin's going to jump in with some of the new exciting updates that we have recently released related to observability around SQL. So I think before we jump into any of those topics, it would be interesting to hear a little bit more about Yohana, Scott, and just a little bit about your company, what you do, and why you were founded.
Yeah, thank you. Yohana is a really interesting beginning. Yoki Matsuzoka, who is our founder, was at Google and back leading the Nest organization. At the time, she realized that she really wanted to focus on bringing health to the home. So Yoki began looking for collaborators and found one in Panasonic who coincidentally shared Yoki's vision. So we formed a wellness company as a fully funded independent subsidiary of Panasonic. In those early days, we partnered with Panasonic to identify existing and new consumer electronic products that we could bring to market in this wellness brand. Then the pandemic hit, and soon we were all working from home, experiencing many of the same struggles that our families and friends here in the US and around the world were experiencing. This new realization that helping people to unload some of the distracting challenges of their lives could be a form of wellness. So we shifted our focus on helping families to find that balance, prioritize well-being, and just to be more present for each other.
Yeah, that's great. I know that sounds like something that I could use in my life. So what can you tell us a little bit more about your product offering?
Yeah, well, in the early days, many of our team was at Nest with Yoki, and so many of our folks were key members in building out the initial Nest IoT platform. And as Panasonic having a large number of consumer electronic products, we started off in the direction to build a multi-tenant platform for IoT. This kind of led us to searching for a distributed database solution, and brought us to CockroachDB to learn more about the product.
Awesome. Yeah. So it sounds like you really started using CockroachDB from the start. And it was like the first database platform that you guys started building on. Yeah,
we were really in the early stages of evaluating that platform. We had not started building services yet, but knew that this was having a distributed database solution was a problem that we needed to solve.
Yeah, definitely. So what were some of the requirements that you were looking for in your database?
Yeah, I mean, our product requirements were still being defined, but one of the things that we knew based on our past experiences, we needed to determine a data persistence scheme. And one of the product requirements that we did know at the time was that we needed to support a global user that might have had multiple properties, homes. And while this was a slim use case, we wanted to make sure as possible that those users could be part of a family of homes. But we also knew that this would create a latency issue for us. So to achieve what we were looking for, we needed the ability to have row-level geographic partitioning. This allowed us to place the data in one region, such as the West Coast, to other regions of the continent and not require cross-continent latency delays.
Right. Yeah. And that led you to distributed SQL, of course. So, yeah. And there's obviously a very large use case there for distributed SQL. So I think maybe this could be a good time, Kevin. You are super, super close to the product on a daily basis, and you have a very good sense of, like how everything works and how it works from multiple different layers. Do you want to just give like a quick overview for the audience on like a little bit about the architecture of distributed SQL and how it works from a performance perspective?
Sure. Sounds great. Basically, first touching on kind of Scott's use case here. A distributed SQL database, it's a single logical database that is easily deployed. The data is easily replicated and scaled across multiple nodes, right? And these nodes can reside across multiple region locations. So this does not only give you resiliency, but distributed SQL also provides flexible data placement strategies to enable high-performing global applications, as like with Yohana. And so, for instance, CockroachDB, we have multi-region capabilities where you could directly use SQL primitives that enable you to define a table as global or regional by row. And these table localities can help you optimize for global reads and writes, or optimize for regional, global reads as well, right? And so it's all really dependent on your application requirements to maximize kind of global performance or reduce kind of network latency, as Scott mentioned. And so in addition, CockroachDB, we have a distributed cost-based query optimizer that's built from the ground up, right? So it takes advantage of CockroachDB's internal distributed storage layer, and as well as kind of the multi-region SQL primitives, right? And so the optimizer, we have capabilities and rules such as locality optimized search that helps the database avoid sending requests to nodes in other regions where data can be served locally, right? And so the optimizer is consistently preferring to read rows locally in local regions when possible. So that's really touching on Scott's use case around multi-region.
Right, absolutely. Yeah. Cool, thanks for that. So it sounds like, yeah, you have this multi-region use case for CockroachDB. What actually is like the application that you're building in a multi-region manner?
Yeah, so we built, making sure I wasn't on mute. Oh, sorry. So we built a global microservice-based application on CockroachDB that allows us to store user data and expect global consistency and high availability traits.
Right. And that consistency is another huge aspect, right? That you want to have this great low latency in a global way, but also have the data be consistent. And that is one of the unique aspects of distributed SQL as compared to like a NoSQL database.
Yeah, I mean, and specifically with this application, we're storing user data that might include tasks for our families that Yohana manages on behalf of their users, additional metadata, user preferences, et cetera.
Yeah, absolutely. So yeah, we often do see that our customers are storing business critical data. So it's the stuff that is actually happening inside the applications that's interfacing with users. So that definitely aligns with what we see with our customers. So one of the things that we do hear some customers say sometimes is that maybe if they have experience in the past using a database like Postgres or MySQL, something that's not distributed, their developers sometimes encounter kind of like a learning curve when they start using a distributed database. There's just a lot more tips and tricks that they have to keep in mind to get the right performance, or performance on par with one of those more legacy databases. So did your team encounter any of that learning curve when they started using Cockroach?
No, not really. I mean, the learning curve, I understand the challenge, but the distributed SQL database was pretty familiar to this team, having worked at Google and on Spanner.
Yeah, okay. Yeah, that makes sense. So if you didn't know, you might know this, that actually our founders used to work at Google and they were inspired by Spanner to build Cockroach. So it sounds like they're all on the same page. So Kevin, just for some context for some of the listeners, I know you encounter this a lot in your daily job, but people who maybe don't necessarily know how to develop against a distributed SQL database. So what are some of the tips and tricks that you recommend to people to get the best performance?
Yeah, sure. So going back to Scott's kind of experience as well, right? I think it's as I mentioned, it's a distributed CockroachDB. It's a distributed SQL database that's basically just a single logical database, and I think scale, right, is the key characteristics of a distributed SQL database. And before diving into kind of learnings as well, I do want to call out there's multiple dimensions of scale we can really talk about here, where it's either adding more nodes and increasing compute to your cluster without any downtime. There is automatic rebalancing of data as well as you add more nodes, or even as your data grows in size and scales, there's automatic rebalancing, right? So in summary, you can easily add nodes, insert more data where database will automatically handle redistribution across the entire nodes. So there's no need to kind of shard your data as you would with other kind of monolithic kind of database architectures, right? And so it really helps kind of reduce the operational complexity of your database when scaling out. And so diving into kind of why is it important to have even data distribution. There's also scale in terms of query execution across an entire cluster. So I think I mentioned before, CockroachDB, we have a distributed cost-based query optimizer where query execution is, it's distributed where it allows each node to process data that it stores locally, right? So it reduces network latency, and when data distribution is evenly balanced, this allows compute to be better parallelized and ultimately reducing the time it takes for queries to complete. And so there's horizontal scaling nature that you need to kind of also consider in mind when you're thinking about working with a distributed SQL database. And then finally, there's also kind of scale in terms of spreading reads and writes across the entire cluster, right? So not only at the execution level, but a distributed SQL database like CockroachDB, we allow scaling both reads and writes across the entire cluster. So you connect to any node where that node would have a complete view of the cluster, and you're not bottlenecked on a single node for reads and writes, right? And so knowing this behavior, though, I think this really points out to some learnings that we have as well from users, where there's somewhat of a distributed mindset, a distributed SQL mindset you should have when designing your database, right? Or running your workload, especially with like database schema design. That's, I think, one of a interesting topic here that we see users also kind of having to kind of understand a bit to kind of take advantage of the horizontal nature of CockroachDB's architecture. So a few examples here is like selecting the appropriate primary keys, making trade-offs between natural surrogate keys with respect to a workload, where you want to make sure that you evenly distribute data evenly across a cluster on ingestion, right? And so you want to avoid sequential monotonically increasing IDs or keys to kind of, I guess, again, spread that load across the cluster, take advantage of that parallel compute, right? And so we have things like SQL primitives like hash sharded indexes, right? That allows you to distribute writes evenly across a cluster and reduce hotspots. We have, I think we mentioned with Scott as well, around multi-region, right? There's SQL primitives around ensuring you select the right table locality, right, for minimizing network latency for global applications. There's other best practices around dealing with contention. Like we have with a distributed SQL like a CockroachDB, we also support the highest consistency levels of serializable isolation, right? And so we are able to process large volumes of concurrent transactions, but this can lead to contention. So there is best practices around making sure you have client-side retry logic, making sure that you're really setting statements in a single batch, reducing the size of your transactions. So CockroachDB can automatically retry on your behalf. So we do have built-in retries as well for some of these scenarios. But I guess these are the kind of top things that come to mind around when designing your schema, optimizing for performance. These are kind of the characteristics that of a distributed SQL database you should keep in mind.
Yeah, absolutely. And we have pretty good docs, or very good docs on a lot of these like tips and tricks, because that is, sometimes we do have customers who will say, they're not necessarily getting the SQL performance they want out of Cockroach, and then it's like, well, you need to learn, to learn a new set of skills sometimes, and then once you do, there's a lot of power that's available to you. So thank you, Kevin, for being someone who works on this a lot and is constantly thinking about how to improve the customer experience for that. So I know, we talked about multi-region quite a bit, and it sounds like that was something that you really wanted to implement to reduce latency and improve performance, Scott. So what has been your experience there with, getting the latency that you require for your applications?
I think the experience has been fantastic, and I think one of the things for this audience that I'd like to highlight is the partnership that we've had with the CockroachDB team. While we understood distributed databases, and we set out to with an aim to for more requests per second, we worked very closely with the Cockroach team to enable faster regional writes, to allow for more requests per second to handle our global traffic.
Yeah, definitely.
It's been a great partnership.
That's great to hear. Yeah, we know sometimes this can be a little complicated, so we want to make sure that we're providing you with all the resources you need and expertise you need from our team to make that happen. So that's good. Definitely good to hear. So, sometimes in whether an application's in production or you're testing it out, there are a lot of optimizations that have to happen, right? And I think I know we've worked a little bit with your team, Scott, on some of our newer features, which are exciting, that just came out in the past release. So before we dive into those updates, though, Kevin, do you want to give like a quick overview of the tools that are available in case anyone is running into performance or SQL performance that's not what they were expecting or what they're hoping to see?
Yeah, so for CockroachDB, we have a native out-of-the-box kind of console experience today, where you can immediately spin up a CockroachDB cluster and immediately use this console without any other setup, right? It's immediately available out of the box. So you don't need to kind of use SQL to introspect any observability information. It's all surfaced in a nice kind of UI when you're troubleshooting and optimizing for performance. If you are familiar with SQL, we also surface system SQL tables as well, so you can actually interactively query observability information from some of these system tables as well. We support kind of similar commands like the explain command that allows you to troubleshoot query performance, or I guess in terms of the query plans that are generated by the optimizer. So these are kind of like the main three touch points: our console, system tables, and like various SQL commands as well, like explain, that helps you kind of optimize for performance.
And then because you're an overachiever, you decided to go out and build a whole new tool for the most recent release, or extend the capabilities. You want to talk a little bit about insights?
Yeah. So over time, we realized that engaging with customers and users, like performance is really not enough without kind of ease of use, right? So especially with the distributed SQL database, we capture a lot of critical information around a workload for observability. However, we see users, they don't really understand where to start sometimes, or what to do with the observability information, right? So we decided to take a much more proactive approach towards observability. And the goal here is to reduce the cognitive load, reduce the concept count around how to maximize workload performance, right? So we built, as you alluded to, Megan, around this the feature called intelligent observability in our native console. So, so these insights here, it helps users address issues reactively, but mostly proactively. So you can quickly prevent issues and discover optimization opportunities in a CockroachDB workload to reduce costs and ultimately increase performance. So yeah, we are much more kind of intelligent with our observability information now, and so we're surfacing recommendations and experiences that leverage kind of our observability information to guide users to much more actionable mitigations.
Yeah, and that was just like I mentioned, we just released that in December with our latest release, and I think we've been getting a lot of really positive feedback. But Scott, your team was one of the first people to actually use this new tool, and it sounded like they had some good results from it.
Yeah, I previously relied pretty heavily on the CockroachDB console and the analytics being provided by the Cockroach team. Specifically the Cockroach team helped us narrow down query contentions and write performance. But I think now with insights, we're able to view the type of indexes that were created but were not being leveraged. We're able to remove and rewrite those indexes to enable faster writes. So we also discovered tables with higher contention SQLs. We're able to rewrite our read-write SQLs to reduce contention periods.
Yeah, and that's really helpful. And that's in a team of people who, have familiarity with Spanner, and we're still able to provide them additional insights. So I think there's always more learning that can happen. And Kevin, again, thank you. I'm just gonna, my theme's gonna be thanking Kevin for.
Yeah, I mean, there's a lot of kind of, and this is kind of the first step towards being more proactive, right, with kind of observability information. So I think Scott mentioned on high contention, unused indexes, and we're constantly going to be building new recommendations and suggestions moving forward through this kind of insights experience. So I'm very excited to kind of see how this evolves over time.
Yeah, and I remember when we were talking about this a few months ago, one of the things we were talking about is let's give developers the tools of a DBA and just give them this knowledge. So I think that's definitely another theme we're building towards, empowering developers a lot more to be more knowledgeable about the database performance.
Exactly.
Cool. So, we're reaching time here, so we'll start wrapping up. But I'm just curious to learn just a little bit more about Yohana, Scott, and like what your future direction is, where you see your growth, and all those exciting things.
Yeah, Johanna, it's been a really exciting journey. We originally launched the assistant service in Seattle, then launched in LA. We've recently made it available nationwide and launched in Japan. I think we'll continue to see expansions in the various markets in the US and Japan, and then in other countries. Additionally, as I mentioned at the start of the segment, we are a wholly owned subsidiary of Panasonic. Panasonic is a consumer electronics company, and we have a lot of experience with IoT. So we continue to explore new products that align well with this wellness theme at Yohana. And so I'm excited to see those efforts, the fruits of those efforts, start to make its way into the market. We're excited.
Yeah, definitely. It's very exciting. Well, I'm gonna go check it out since I'm in New York. So it sounds like you just recently released in New York, and I could definitely use some assistance. So thank you. All right, so I think that's it for today. Anything else that you want to add, Kevin or Scott, before we wrap up? All right.
No, I think that's it on my side. Yeah.
Okay.
Yeah, I just want to thank you for the continued support of Yohana and the partnership that we've had to date, and looking forward to future projects together.
All right, so we are back after listening to the recording of Yohana that we recorded last week. So again, thank you everyone for jumping in with all the questions throughout the session. For those that we haven't been able to answer, we'll try to get answers to you during the next few minutes, and if we can't, we'll reach out to you afterwards with responses. But we are actually now going to jump over into a demo that Kevin is going to show of the new Intelligent Insights Observability tool that we released about a month ago. So we'll be able to get a little bit more technical and see exactly what's going on here with some of the performance optimizations. So with that, Kevin, you ready to share your screen?
Yeah, sure. Let me share my screen and let me know if you can see it, Megan. All right. Can you see the console?
Yep, we're all good.
Okay, so I think I mentioned a few questions. I addressed a few questions in the chat. Basically, CockroachDB, we have a native out-of-the-box console experience that allows you to monitor your cluster and troubleshoot and prevent issues from occurring that is stemming from CockroachDB. And so now I'll do a quick demo of the new Intelligent Insights experience. Before diving in, I do want to provide a brief overview of what insights are, right? And so we introduced Intelligent Insights in 22.2, the release of CockroachDB, where it enables, I think I mentioned it on the recording, but it's a proactive performance tuning and troubleshooting experience to help you find, fix, and prevent workload issues from occurring and impacting your application. And so at its core, Insights detects execution outliers. So basically slow statements and transactions. So you can think about it as very similar to a slow query log. That's very similar to other database systems, if you're familiar with other systems. But it also tracks it at the transaction level as well. And so it's always on, and we capture information both in system tables, so you can use SQL to interactively inspect those tables, or use the console here and see the slow executions of your statements and your transactions. The process is a very lightweight tracing process. So for execution insights, there is there's negligible impact to performance of your workload. And so when a statement is detected, we have a insights classifier that will categorize and surface potential performance optimization for that one execution. So jumping into the demo here, as you can see here, there's an Insights tab here where I've gone to the Workload Insights tab, and there's a drop down between both transactions and statements. So you can drill down at both levels here, the transaction, the full scope of a transaction, or dive directly into a specific statement, where at each level there are various insights that can help you determine how to optimize performance for your workload. So in this case here, I'm at the insight, the statement executions, where you can see here, this statement here has a suboptimal plan. So the suboptimal plan here is basically determined by our recommendation engine with CockroachDB that's always on. And we surface the specific index that should be created as well. And so again, the goal here is to be as prescriptive as possible, where you can really see that the statement was slow due to a suboptimal plan, and you can see which index is required to speed up that particular statement. So in this case here, we needed an index on the users table, storing the name column as the key, and storing the credit card information to that index as well. Note, we do support one-click mitigation as well as part of this experience. So you can immediately apply this index to your table to speed up the statement. Note, this is very familiar. This is helpful for development and development environments, and this is guarded by appropriate SQL privileges as well. So you should have create privileges to be able to create and see this create index recommendation. We also capture things like the explain plan as well. So if you want to inspect to get more context and detail as to why that statement was performing slowly, you can immediately use this console page here to see additional details. So that's for the scenario of when a statement is slow due to a suboptimal plan. We have transaction executions as well, including insights at that level. So as I mentioned in the recording here, an interesting kind of problem that we see users typically troubleshoot is around contention. So we surface transactions that have high contention, in this case, high wait times as well, directly in the console. So when clicking into this transaction here, you can see that this transaction experience spent time waiting 322 milliseconds, where it was waited on this other transaction to complete and release the lock, right? So this is basically lock contention, very similar to if you're familiar with other database systems. This is basically surfacing lock contention and wait times in this UI, so you can actually go from one transaction to the next and understand kind of this contention chain and understand what's the most highly contended transactions you have in your workload. Next, going back here, we also have schema level insights. This is looking at not specifically executions, but a summary view of whether or not there are optimizations around index tuning and maintenance, right? And so in this case here, we have a few drop unused index recommendations given given our index usage statistics, right? Given the number of reads on this index. In this case here, this index hasn't been used for over 5 minutes. This is kind of just for demo purposes, but our default value is 7 days. So whenever an index has not been used over 7 days, we will surface a drop unused index recommendation where you can drop it directly in the console here. Again, you have to have sufficient privileges, and it's typically not recommended for production environments, but you can do this easily in dev test environments, and even copy the SQL syntax and send it over to your development teams for integrating in kind of your continuous integration deployment pipelines. We also lead you to the index details page as well, so you can see how many reads, what was the last time it was read. And you can also bubble up to understand which table it is, right? And other details around the size of the table, regions that the table resides in, as well as kind of stats information as well. And let's see here. I think other than that, there's other insights here around whether or not just slow execution. Again, there are some scenarios where we don't detect. And so again, this is very similar to the slow query log where we just capture slow execution. So this is very helpful for correlating metrics with execution outliers, right? So in CockroachDB, we have this metrics page as well that allows you to kind of see spikes and dips of kind of performance over time. And you can even correlate that with your insights as well to see what's causing a particular spike and potentially CPU utilization or kind of latency as well. And yeah, I think that's kind of the main experience I wanted to at least demo here. And I'm happy here to take questions.
Thanks, Kevin. That was awesome. So it looks like we had a few questions coming in specific to your
Sure.
demo. If you want to just take a quick look at the Q&A and see if there are any you want to answer.
Sounds good. Let me take a look here.
And again, the questions that we aren't able to get to will follow up afterwards in an email.
Yeah, so Carlos, you had a question on are there any AI capabilities with Cockroach? I think this is, if you're speaking in terms of how do we detect, recommendations, right, or I guess index recommendations, because right now there are no kind of ML models that we built into CockroachDB yet, but that is something that we are looking forward to kind of integrate in the future to provide much more proactive and prescriptive kind of observability experiences. So we do want to be able to start embedding models to allow predictions around indexes for an entire workload, right? Right now, as I mentioned, it's a single statement recommendation, but we are kind of looking into ways on how we could start mining the data to understand how we can make this more of an automated and much more prescriptive experience when kind of in the kind of workflows of troubleshooting performance issues. Let's see here. Let's see. I see a question here from Anoop as well. One is, what is the retention of these logs and how to manage it? And what are the options to make these logs available for a bigger audience, right? So I think this is a great question here. Currently, in the first release of Intelligent Insights here, retention period is scoped to the number of rows. So all the information here is stored in our system tables, where we have a retention limit of about 1,000 rows per node. So it also depends on how big your cluster is. But we are looking into ways, and we have a few features in our roadmap to persist information for longer term retention and even offloading it to other third-party application performance monitoring tools as well. And I think you also asked around options for making these logs available for a bigger audience, right? So we are improving our permission model here within the console too. So we have improvements around fine-grained access controls, where we'll be able to limit who can see what in the console. In this case here, we've seen use cases where you're able to have just developer access or privileges that will give developers or a broader audience within your team to have access to these specific workload insights pages, and not have access to other potential information like the advanced debug and in this case hot ranges as well that could surface some information that your developers should not have access to. So we are looking into ways to have a much more fine-grained permission model here in the console. Let's see. I think there's insights available for CockroachDB core. This was a question from Junaid. Yes, so insights is available for all, I guess, flavors of CockroachDB, CockroachDB core, CockroachDB dedicated, and CockroachDB serverless. I think serverless is rolling out soon. It's not available today, but it will be in the future. So insights is kind of out of the box. It's not an enterprise feature. That was kind of what you were asking here as well. I think Hari also asked, is there any part of CockroachDB open source? CockroachDB is, I think any parts, I guess in this case, insights here, it's open source. It's available again across all flavors of CockroachDB.
Maybe we'll take two more.
Okay, sounds good. Let's see. I think Murali, you had a question. Does CockroachDB have the capability to check inter-database queries where the query has performance issues? So that's a great question, Murali. I think right now in the console, we do surface the explain plan. So you can see the logical plan and see how it's going to be executed across the cluster. One thing that isn't shown here is the physical plan, which you can do by running explain analyze. And on CockroachDB, we actually show a distributed form of the explain plan as well. So you can see how it's distributed across multiple clusters. And so I'll definitely recommend you to take a look at our explain analyze and even our explain analyze debug, which has much richer information around how the query is executed across a cluster with even trace information as well, if you want to get to that level of detail. Excuse me. And yes, Anoop, all nodes, the question here is each node stores its own logs. Yes, all nodes have its own set of logs. I think, as I mentioned, has a retention limit of 1,000 rows per node here. But yeah, I think that's all we have time here for questions.
Yeah, I think that's all we have time for this session. But again, we'll have someone follow up to answer questions that we were not able to get to live. And as well as that, we'll be sending a follow-up email so you can access the recording and some more resources just to learn a little bit more about what we are talking about today. And then, of course, for the 50 people who are going to be drawn out of the raffle to win the t-shirt, you will definitely be hearing from me as soon as we draw the names out of the raffle. So just wanted to give a big thank you, Kevin, to you for taking the time to go through all of this information today. And anything else that you wanted to add before we wrap up?
No, I just want to thank you everyone for joining the webinar, and thank you, Megan, for facilitating. It was a great session and great questions as well.
Yeah, thanks for all the great engagement. We appreciate it, and you'll be hearing from us soon. All right, thank you all.
Awesome. Thanks, everyone.
Bye.